Good afternoon. This is Kyle Welch with RCR Wireless News. Thank you for attending Guarantee Mobile Device Performance presented by Ixia. Our presenters today are Sean Baioni, Wi-Fi Business Development at Ixia, and Cinerama Penumetsa, Product Manager at Ixia. With that being said, I'd like to turn the presentation over to Sean.
Thank you, Kyle. And good afternoon, everyone. Thank you for joining us today to discuss guaranteeing mobile device performance. My name is Sean Baioni, and I've been helping device companies and carriers develop fantastic Wi-Fi solutions for the last 6 years. Let's start by moving to the next slide, please. Before we dive into the details, let's look at a few trends in Wi-Fi that are making guaranteed performance an elusive goal today. First, the sheer scale of Wi-Fi connected devices is continuing to grow at a staggering pace. ABI research estimates as many as 7 billion Wi-Fi enabled mobile devices by 2015. Most devices will be wireless only. Network plugs will not be an option. Every kind of device that you can imagine, from cars to home appliances, will be on Wi-Fi networks. This growing accessibility to Wi-Fi is leading to an increase of BYOD initiatives in hospitals and the enterprise, pushing the importance of accessing always-on mission-critical applications. Also, the new standard 802.11ac will allow speeds of up to 1.8 gigs and multi-user MIMO to help with the before-mentioned increase in client scale. Carriers worldwide are happy to see 802.11ac as their need to offload cellular data from expensive LTE networks to more cost-effective Wi-Fi ones grows. Next slide, please. Now let's look at some micro trends driving Wi-Fi device design and making guaranteed performance difficult to achieve. As Wi-Fi continues to complement and compete with other wireless technologies such as LTE and Bluetooth, radios are being placed closer together, not just to save space, but also money. In the case of MIMO, multiple in, multiple out technology with 802.11n and AC, the task of reducing noisy interference inside the device is becoming more daunting. Also, the continued use of legacy devices on modern networks is adding layers of complexity to rate adaptation and roaming algorithms. Once early adopters like hospitals and K-12 schools are struggling to handle the integration of new 802.11 devices, which are capable of much better performance but are held back by sharing the legacy medium. You can't really blame them. I mean, they're just trying to get back their ROI, but it's a major problem. Finally, mission-critical applications like electronic medical records in a hospital not only need rock-solid, always-on connectivity with excellent QoS, but must also maintain energy efficiency for longer battery life. These micro trends are driving a huge gap between conventional Wi-Fi device testing and the new testing we're going to show you today. Next slide, please. On top of these macro and micro trends, we've taken on a connected identity with the expectation of not only being socially available to the important people in our lives, but having access to all our favorite cloud apps everywhere. We all expect to guarantee that our mobile devices will achieve high performance, whether at home downloading pictures, at a hotspot doing some holiday shopping, a hospital reading WebMD, at work on a video conference, or even on a plane passing the time watching TV. Let's go a little bit deeper into the specifics of how these diverse environments make guaranteeing performance difficult for all solution providers. Let's examine the case of my smartphone during an average day. Next slide, please. A few weeks back, I was able to watch the pilot episode of Breaking Bad over in-flight Wi-Fi, which is totally cool. Not just the show, but the fact that we can get Wi-Fi on a plane is incredible. Okay, I'm culturally 5 years behind by starting to watch the show now, but because of my mobile device, I have a decent chance of watching every episode before someone spoils the ending for me. And please don't spoil the ending in the comment box today. That would be great. So when I wake up in the morning and connect to my home Wi-Fi network, there are several challenges I face getting that day's episodes on my phone. I need high bandwidth, but I'm in the presence of dozens of other Wi-Fi enabled devices needing the same high bandwidth, like a webcam, not to mention other wireless interfering devices, all on a single home access point at multiple distances throughout my home. Why multiple distances, you ask? Well, I'm chasing my 4-year-old daughter around the house and trying to get her to eat and comb her hair before school. I could be the only one with that problem, but I doubt it. If I don't get the episodes loaded on my phone, then I need to hope for excellent QoS as I transfer my Netflix streams from my carrier's LTE network to free Wi-Fi hotspots on the train or at Starbucks. Once again, dramatically different ecosystems, and now the challenge is streaming video reliably instead of downloading large files for later use. What are the roots of these problems I'm having? Slow Wi-Fi speeds could be bad radio hardware or integration. Choppy HD video could be poor rate adaptation algorithms by my device. Finally, poor connectivity and roaming could be bad integration of the radio hardware and software stack. This is why we're discussing a new comprehensive way to test Wi-Fi devices in order to get consistent high performance. We need multiple system layers running flawlessly. Let's go to the next slide, please. Next on my little adventure here with my phone, I'm out of the house and I'm going to drop by a hospital on my way to work and see how some FDA Coexistence Testing is coming along for a medical device company I'm working with. I get on the hospital's BYOD network for vendors and I transfer an updated test plan from my cloud Dropbox app. I notice a doctor walking by is using the same device I have to fill out a prescription on the hospital's enterprise Wi-Fi network with coexisting heart monitors, infusion pumps, and x-ray machines. While leaving to my office, I log on the cafeteria guest Wi-Fi network for 5 more minutes of Breaking Bad. I know it's a desperate move, but my wife is way ahead of me. My point is that my device needs to operate on at least 3 different kinds of networks in this environment, all highly secure due to HIPAA regulations, and be non-interfering with the patient care mobile devices as per FDA regulations. Although my device works great in this environment, not all do. And how can vendors guarantee performance? Well, I believe to pass new coexistence guidelines from the FDA, radio hardware system integration is going to need a breakthrough and new innovative ground. Remaining connected while roaming on a hospital campus with tough encryption is going to require fantastic algorithms. Some hospitals certify performance on as many as 125 Wi-Fi devices a year in every location, channel model, and application in the environment. For this reason alone, a new device testing approach is needed, and we'll show you that in just 2 more slides. I can talk about medical device testing all day long. If you're interested, please call me or watch another webinar on our website, ixiacom.com, for more on this topic. But let's go to the next slide, please. Finally, I reach my office to use Wi-Fi to attend several conference calls over unified messaging. Some are audio only, some share screens, and even others have live video with customers. Unified messaging challenges could be related to my device's buffer management, which can greatly hinder unified messaging performance. Problems with roaming may lie in the device's drivers or an algorithm that makes my device too sticky. Interoperability with network access points can also produce poor unified messaging results. I would always recommend a site assessment for the specific application like Link or Jabber, not just a site survey, but an application-specific site assessment. I hope I've made it easy to see why we need client testing to be on par or even exceed AP testing when we consider how much more we expect from our mobile devices every waking minute of the day. Final slide for me, please. In summary, performance problems of mobile devices are very difficult to figure out, not only because of the device's complex system components, but they're also being challenged with more and more demanding performance expectations, while the sheer scale and coexistence of other Wi-Fi devices increase the difficulty of tasks like roaming and connectivity. As I mentioned, slow download speeds may be caused by bad radio hardware, choppy Breaking Bad video playback might be poor MAC aggregation. Bad roaming algorithms could cause clients to disconnect from the network. With so many challenges to guaranteeing device performance, we need a new methodology and a new test tool that can cover all these variables quickly and effectively in one solution. I want to turn the presentation over to Ixia's Wi-Fi product manager, Cinerama. Maybe he can take out all the doom and gloom I pointed out about Wi-Fi device performance and light the way to sustain success. Cinerama, take it away.
Thanks, Sean. Good afternoon, everyone. In my part of the presentation, I'm going to talk about the technical challenges with Wi-Fi devices in delivering end-user quality of experience. I'm also going to talk about common device issues and best practices to guarantee mobile device performance. So for any Wi-Fi device, there are three main areas to look into. The physical layer is responsible for converting information into RF signals and transmitting them between the source and the destination. To ensure successful communication, the transmitter and the receiver of the device need to perform well and conform to all the specifications. On the performance side, the transmitter needs to have proper transmitter modulation accuracy at different modulation rates, and the receiver needs to have a low error vector magnitude when receiving at various data rates and power levels. On the functional side, the transmitter needs to make sure that the RF energy transmitted is confined to the allowed spectrum mask within the frequency band of operation, and needs to ramp up and ramp down power within the spec to ensure any given transmission does not interfere with the next one. A proper PHY layer is super critical for ensuring end-user quality of experience on a Wi-Fi device, and so RF testing is actually a very essential step. Now, the MAC layer is the meat of the Wi-Fi protocol, and hence a large portion of the .11 spec actually defines the behavior of the MAC layer. Now, unlike other wireless access technologies like LTE, where the base station makes most of the decisions for the device, the Wi-Fi protocol requires the client device to actually make lots of decisions. The device has to decide when to transmit, how to contend and acquire the medium, how to roam between access points, how and when to rate adapt, and how and when to implement power save mechanisms. So a typical Wi-Fi device is expected to be a lot smarter and needs to implement several complex algorithms at the MAC layer. And hence the MAC layer on the device needs to be tested thoroughly, both on the functional side and on the performance side. On the functional side, the device needs to be tested to make sure it can roam, rate adapt, can connect to the AP using proper security mechanisms, and can only connect to APs with matching credentials. On the performance side, it's important to test that the device can optimize its resources to maximize throughput, implement proper traffic classification under load, and also minimize battery consumption. And then, of course, we have the application layer, which is what the user sees and interacts with. So as Sean mentioned, we have a number of functional and performance aspects of application performance, including issues like seamless LTE to Wi-Fi handover, delay-sensitive unified communication applications, high-definition video streaming over Wi-Fi, and so on. Now, one of the very important points to note here is bad RF performance or bad MAC layer performance will result in bad application user experience, as all these layers are very interdependent on each other. So it's important to thoroughly test and harden a device at each one of these layers in isolation, and then test the system as a whole. So to tackle these challenges, testing is best done using a staged test approach. It's important to baseline the performance of the device and the test under ideal conditions, find and fix issues, and then introduce one variable at a time, step and repeat the testing as we move along from the most deterministic form of testing to the most realistic form of testing. So this slide shows a staged approach for testing Wi-Fi devices as they go through their life cycle. So during the development test and QA phase of testing, configurability, repeatability, stress, and automation are super important to get maximum test coverage in a minimum amount of time. So this form of testing is best done using a piece of test equipment that can simulate an access point. Then at stage 2 of testing can begin during the post-production phase of the development lifecycle. So the device is now fully developed and has to be tested as a system before release. So in this stage, it's important to subject the device to more realistic test conditions, which include testing against real APs and testing over the air. And then the final stage of testing would be when the device is deployed on a live network. So it's important to characterize the behavior of the device in real-world conditions, find and fix the small percentage of issues that actually fell through the cracks during lab testing. Also, you can validate that the network into which your client device is being deployed has no major issues and can therefore support reliable operation of your client device. So we have often found that some of our customers are tempted to actually skip the first two stages and directly go to stage 3, and then they find real problems in the field and then wonder which one of these countless variables actually caused the problem. Is it the device? Is it the network? Or is it the interoperability between the device and the network? Or is it RF conditions? So, and stage 1, the key tests that need to be run include measuring radio performance, as we mentioned before, general device connectivity, measuring raw throughput, protocol conformance, and other MAC and physical layer protocol related aspects like roaming, rate adaptation, power save, and security, and so on. Now, extensive test coverage is very important during this stage, and covering a lot of test cases in a small amount of time is critical for an on-time release of a high-quality product in a highly competitive market. So when we looked at the state of art today for Wi-Fi device testing in the lab, we noticed that our customers use a number of test tools from different vendors. They use an AP simulator tool from vendor A, a traffic generator tool from vendor B that can drive traffic between the AP, simulated AP and the client device. They use a programmable attenuator from vendor C to simulate distance between the AP and the client for roaming and range testing. They use a channel emulator tool from another vendor for creating multipath environments. And then for RF and protocol analysis, they use signal analyzers, generators, and sniffer tools, again from different vendors as well. Then they try to put complex test beds together with all these tools from different vendors, and often end up having to figure out answers to questions like how do I learn to use all these tools? How to create a single automation framework involving all these tools, and how do I correlate and consolidate results from each one of these tools to perform root cause analysis. So at Ixia, we created a revolutionary new approach for device testing by creating a single box solution from a single vendor that performs all the functions listed above, significantly reducing the capex as our customers don't have to purchase 6 different tools from 6 different vendors, and also significantly reducing operation expenses as there's only one tool to learn, one tool to automate and cover all the test cases in their test plan, and one tool that can provide test results for the physical layer, MAC layer, and application layer testing, along with real-time results and expert analysis. Now, we call this product Wave Device. So let's talk about how this Wave Device solution works. The Wave Device solution is a combination of hardware and software. The hardware, as I mentioned in the previous slide, has a 802.11a, b, g, n, AC golden access point emulator. It also has a full line rate traffic generator. It has a channel emulator, a distance emulator, and a line rate real-time protocol sniffer, and a line rate real-time signal generator and analyzer, all built into the same piece of hardware. The test hardware is connected to an RF enclosure using RF cables, and the device under test is placed inside the RF enclosure. The device under test runs a simple endpoint software from Ixia that sits at the transport layer on the device and can receive commands from the Ixia Wave Device hardware to send and receive different types of traffic at different rates and make precise performance measurements. So the test hardware can create and broadcast one or more wireless networks of different types, and the device under test can connect to the test system just like it would connect to a real access point, and get an IP address from the DHCP server running on the test system. Once the device is associated with the golden AP, the test system then communicates with the agent software on the device under test. The test system will also emulate the servers behind the wireless network and hence can set up upstream and downstream traffic flows between the servers and the agent software running on the device under test. Now, with this test methodology, our customers can start with a simple baseline test under ideal conditions and measure the maximum possible performance of the device under test, and then start adding one variable at a time to the testing in the form of distance emulation, multipath effects, interference, background load, and check how each variable actually affects the device performance. Now, since this solution is fully integrated layer 1 through layer 7 tester, the users can correlate bad application performance to either bad Mac performance or radio issues, and then narrow down to the problem area very quickly. So I thought I should share some very interesting findings from the test that we ran on some of the most popular latest and greatest laptops, tablets, and smartphones that we were able to get our hands on. Now here's an example of a test that we ran using the Ixia Golden AP test tool. In this example, the test device used was the latest and greatest 2x2 MIMO 11AC laptop that is available in the market. In the first test, we ran an upstream and downstream throughput test on the device against using the latest and greatest 11AC 3x3 MIMO enterprise class access point available in the market. And the test was run at various frame sizes under ideal test conditions with the device under test inside an RF enclosure and under totally isolated RF environment. Now, we then ran the same test by replacing the real AP with the golden AP from Ixia, and then when we ran the same set of tests again. As you can see from the results, the same client device performed much better in all the tests when connected to the Ixia golden AP. So what this really proved is that in the first test, the performance of the device under test was actually limited by the performance of the real access point. So testing with the golden AP in this case allows our customers to benchmark the true performance limits of the device under test. Now, this methodology also allows our enterprise and carrier customers to conduct bake-offs to compare performance of various client devices under similar test conditions. And our device manufacturer customers can use this benchmarking methodology to ensure that their chipset or Wi-Fi module vendor tests to make sure that the chipset or the Wi-Fi module actually achieves maximum theoretical performance under ideal conditions. So in this test, we compared the performance of two 11AC devices. So both these devices use the same Wi-Fi chipset, but with device A, we were able to measure close to 288 megabits per second upstream throughput. With device B, we achieved about 196 megabits per second throughput when we ran the test using the golden AP again. So clearly something is wrong with device B, as it seems to have a lot more errors on the frames it transmitted. So we then used our real-time line rate signal analyzer tool, which by the way is actually built into the same golden AP card, and measured the RF transmitter quality on each one of these phones. So we found that the EVM on the device that performed poorly was actually much higher. So this is a clear indication of a poor transmitter quality, possibly because of the way the antennas are placed or due to interference from other radio interfaces on the device. Now, with their current tools, a QA engineer who finds this problem of low throughput does not have access to costly RF equipment and hence will not be able to find this out, that it's actually indeed a transmitter issue. And hence, they'll have to pass this problem on to the RF test team, and which causes a lot of back and forth between the teams, wasting a precious testing time. So had they, if they had the Ixia way of testing, there's a single tool that can actually correlate bad application layer performance to bad RF performance, and it's a lot easier to narrow down to the problem area. So next we ran a series of tests comparing the performance of the most popular smartphones in the market today. The phones we use for testing, basically in no particular order, are an iPhone 5 from Apple, a Nokia Lumia, Huawei Accent P6, and a Samsung Galaxy S4. This chart shows the maximum throughput achieved by each one of these smartphones when tested against the Ixia Golden AP. Now, as you can see from the chart, the clear winner in this case was phone B. And if I'm looking to buy a smartphone, given that I use Wi-Fi extensively on my phone when I'm at home or at work or at the airport or even at restaurant, Wi-Fi performance is super critical for me to choose a phone, and I'll obviously pick smartphone B from this test results. Now, this chart shows how well these phones can actually perform frame aggregation. So again, this is a metric that we can measure using the Ixia hardware in real time. So the higher the frame aggregation, obviously, the better the performance of the device in the test. And again, we're comparing the various smartphones here in this chart, showing how well they can actually perform aggregation. Now, this chart actually shows upstream and downstream packet error rates for, again, each one of these smartphones, both in the upstream and downstream direction. And then another very interesting test we ran using the Ixia Golden AP again is the performance over time test. Right? This test was run on a smartphone under ideal test conditions in a fully isolated RF environment. Now the throughput was measured once every 5 seconds for a 30-minute duration, and we noticed that the throughput actually varied anywhere between 80 and 110 megabits per second over the 30-minute test duration. Now, this is obviously not a very good sign, especially when the device is expected to perform consistently in delivering applications like unified communications and HD video streaming over long durations. Now, this is another interesting test we ran. This is a battery life test that was run on all those 4 smartphones to see how long each phone can survive on battery when continuously transmitting on the Wi-Fi interface at full medium capacity. Now, the results were very interesting. As you can see, phone B, which actually had the best throughput, also seemed to have the best battery life, about 5.6 hours, when it was constantly transmitting at about 290 megabits per second. The battery actually lasted for about 5 hours, which is really good. But obviously, the other phones did not do so well. Now, let's actually move on to stage 2 of testing. So stage 2 of testing, if you remember, it should be done when the devices are actually fully developed and all stage 1 issues have been found and fixed. So in stage 2, it's important to test the devices against real access points and basically make sure that the devices can interoperate with these APs when they're deployed. So it's very important to have the right test tools for interoperability testing as well. The test tool should be able to run various tests and measure throughput over distance, roaming, range, QoS, tolerance to interference, and so on when the client device interacts with real APs. Now, the test tool should also provide a lot of visibility into the air interface, isolate and narrow down the problem areas by providing expert analysis. Ixia's Wave IoT and Wave Client test products are again tailor-made for interoperability testing of Wi-Fi devices. Now, this slide shows the Ixia Wave Client roaming and range testbed for testing with real access points. The APs and the device and the test are placed in isolation chambers, fully isolated from each other. The RF management unit, which is the box in the middle of the diagram, is a multi-port programmable attenuator. So the RF management unit lets the user control the attenuation on each port through the Wave Client application software and facilitates the device roams. So for example, by setting 0 attenuation on port 1 and maximum attenuation on all the other ports, the test system can ensure that the device under test can only see and connect to AP1, and the user can slowly increase the attenuation on port 1 and decrease the attenuation on port 2 to roam the client device from AP1 to AP2 in a very, very controlled fashion. Now, the speed at which the attenuation is increased and decreased obviously can also be controlled to simulate different types of real-world conditions, like a person walking or moving really fast between access points. The user can also load a simple agent software on the device in a test and connect data plane tests to measure file transfer times, throughput, jitter, packet loss, etc. Now, the Ixia chassis will be used to capture all the traffic flowing through the system when running roaming tests and other tests, and compute roaming delays and file transfer times and so on. The chassis can also be used to load up the APs with background traffic and test how well the device under test will perform when sharing the available bandwidth with several other wireless clients connected to the same AP. Now, this kind of testing is obviously very useful when the device is expected to be deployed in highly loaded and diverse network environments. Now, the tests on this slide were actually run using the testbed that I just showed in the previous slide. The same 4 smartphones were tested, but this time for performance under distance, over distance. So these tests are run under highly isolated and very repeatable test conditions, and show how the performance of the device under test deteriorated over distance that was simulated using a programmable attenuator. This chart below shows some real test results from a good and bad roaming performance of a device. Now, the charts have time on the x-axis and the device physical data rate on the y-axis. The chart on the left shows laptop 1 rate adapted over a time as it moved away from AP1 and AP2 and then roamed to AP2 and started transmitting at a higher data rate. Now, from the chart on the left, we can see that laptop 1 was quick enough to recognize that it cannot maintain a good connectivity with AP1 and scan for other access points found and connected in, to AP2 quick enough to achieve a relatively smaller roaming delay. Now, the chart on the right shows that there is a huge gap in time from when the laptop to a laptop fully disconnected from AP1 due to low signal, and when it decided to connect to AP2, and hence this was really a break before a make connection, and this resulted in about a 12-second roaming delay. And you can only imagine how a 12-second roaming delay would affect your voice call or your high definition video transmission. So now let's move on to stage 3. So stage 3 of testing brings us to the field. Now, stage 1 and stage 2 of testing provide us an excellent platform for our customers to do everything possible in the lab and ship an excellent product. But we can almost be certain to have some issues that would only show up in the field. So while testing Wi-Fi networks and devices in the field, the common misconception is good RF coverage means happy users. Now, a device could be getting excellent signal strength from all the locations on the floor, but still have very poor performance. There could be several reasons for this. Maybe the device is getting excellent signal in general, but is not connected to the best available access point. Maybe the traffic load is not balanced across all the APs, and hence resulting in low throughput on the device. Or maybe all the neighboring devices are communicating only in the 2.4 gigahertz band, even though there is a lot of free bandwidth available in the 5 gigahertz band. Or maybe it's not even a wireless problem. Maybe there is some policy or role-based misconfiguration on the wired network that's causing the poor performance of the device. So from extensive testing connected in the field over several sites, it actually became very clear to us that the traditional RSSI-based survey kind of testing is actually not good enough. Coverage doesn't mean capacity. It's very important to measure application performance, use the real client device in the test, and test in the actual deployment site. Only then the users can find the issues in the field that were actually not found in stage 1 and stage 2 of lab testing. So it's also important to test the network for client capacity. So does quality of experience hold up at scale? It's important to test for coverage. Do my applications work well everywhere on the network on my client devices? It's important to test for stability. Does the network work well over time? So as an example, here's another real field test issue we found when helping one of our key customers find and fix issues in the deployed Wi-Fi network. Now, this customer used the traditional site survey tools for their testing and basically found all green in the coverage maps, which indicated good signal coverage, but they were seeing very bad performance on the network and constant complaints on dropouts and poor application performance on this network. Now, they turned to Ixia and we used our WaveDeploy site assessment tools. We ran an active site assessment with 4 real client devices and found out that 3 of these devices were connecting to the network on the 2.4 gigahertz band, and there was only 1 client device that was connected in the 5 gigahertz band. Now, all these 4 client devices were getting excellent signal strength, as seen from the mostly green maps in the second row of this table. But it turns out that the 2.4 gigahertz band was so overloaded and had so much interference that the downstream throughput was very bad. It also turns out that the APs deployed were dual band access points, and there was actually a lot of unused bandwidth available in the 5 gigahertz band, and most of these client devices were actually not programmed to find the network in the 5 gigahertz band, and also band steering function was not enabled on the access points. So once the WaveDeploy tool found this problem, we advised the network admin to enable band steering, and all the devices that were 5 gigahertz capable were automatically moved to 5 gigahertz, clearing up the 2.4 gigahertz band, and all the problems magically disappeared with a simple change in the configuration. So to summarize, here are a list of key questions to ask when testing the devices in the field, and make sure that the test tools answer all these questions. So along with answering the age-old signal coverage question, we also need to find out what voice video quality can I expect on this network? How well does the device roam between access points? How many users can we successfully support on this network? What is the end user quality of experience I can expect when the network is fully loaded? And how well do different devices coexist and interoperate on this network? These questions can only be answered by using the Ixia style of deployment testing. So by following the staged approach to device testing, most of the device specific issues can be found and fixed in stage 1 and stage 2 in the lab, and the user can be pretty confident that the devices will work perfectly on a properly constructed network. Now, the only variable left is the network and its ecosystem, and using the active site assessment test approach, the effects of this variable can be characterized and corrective action can be taken. Ixia is the only Wi-Fi device test solution that can help silicon vendors, device manufacturers, enterprises, and service providers go through this staged approach of device testing and provide a common set of metrics to measure and track device performance on its journey through the various stages of its life cycle. So how does one deliver a great client experience? First, start with a standard solution offering such as a reference design from a silicon manufacturer or an embedded Wi-Fi device, a Wi-Fi module, and then customize the generic solution to hit the performance, power, reliability, and physical requirements of your client device. The second step is to then exhaustively test the behaviors of the device to ensure that the Wi-Fi customizations have actually not compromised functionality or performance. Identifying and addressing a handful of issues at this stage can save a lot of angry phone calls and customer support trips after deployment. Now this leads to step 3, which is to tune the design. So test, then tune, then test again, rinse and repeat until you get the behavior you need reliably. Once the device is rock solid on its own, the next step is to ensure it interoperates with the network under all possible realistic environments while testing in the lab. And then finally, test the end user network while performing a major rollout to ensure that the user's network can support a high quality client transaction and that there are no site-specific issues. So with that, I would like to thank everyone for joining us today, and we hope we have been able to provide you with a powerful set of ideas for testing and guaranteeing mobile device performance. If you have any follow-up questions after this webinar or would like to see the Ixia equipment in action, please feel free to contact Sean. His phone number and email information are provided on this slide. Also, please make sure to check out our white paper on actionable insight into Wi-Fi device performance. The link for this white paper is provided on this slide, and we'll also email a copy of this white paper to all the attendees. Back to you, Kyle.
Thanks, Cinerama. Great stuff. We had a few questions come in, the first of which is for Sean. So the first question is, I currently use real APs to do all my device testing. Why do I need an emulated AP?
Well, that's a great question. With the AP emulator, you'll be able to, in the development stage, verify performance, very much like I was talking about with my scenarios. Verify high bandwidth or verify HD video performance or excellent sound quality, whatever the application is of the device. You'll be able to verify that very quickly by running hundreds of automated scenarios, different channels, different channel models, running on AC, 2x2, 3x3, and different encryption types. It would take you a very long time to run through all those scenarios. And for something like medical device testing, it's very important to have a great diversity of testing in the early development and QA stages. And it's certainly important to have that real AP. I would say you can get about 60% of the necessary testing done in a much shorter time period with the golden AP. So Ram, did you want to add anything to that? Nope. Okay, next question.
Okay, Cinerama, the next question is for you. How can you do roaming and range testing?
The roaming and range testing is done by the AP emulator. Instead of using an attenuator which is normally what would be done to create power diversity, the AP emulator turns up and down the power as if a real AP would have a different power density if the client was moving away. So the client can stay still in your test facility, and we will modulate the power of the AP emulator so it looks like it's very close to an access point, like I'm standing under one right now in my office, or I'm very, very far away from an access point, like I'm at a Wi-Fi hotspot waiting for a train, but the access point is, you know, on the other side of the tracks. So we can do that very controllably, very deterministically, and then you're able to verify your performance at all those different distances.
Okay.
The only thing I would like to add is, so using the golden AP approach, as Sean mentioned, we can increase and decrease transfer powers and error rates to cause the device to roam. And then while the device is roaming, we can actually run some application traffic between the device and the golden AP and precisely measure how did the roaming delay affect the voice quality or the video quality and so on.
Okay, great. We have another question for you, Cinerama. It's how much does performance really vary from one device to another?
Yeah, I mean, that's a good question. As you can see from some of the results we showed in this presentation, actually performance can vary quite a bit, and much to our surprise, we have actually we have done a lot of testing of different kinds of devices, and in some cases we tested devices that actually use the exact same chipset, but end up getting drastically different results. Again, this could be because of how it could be a system integration problem. I mean, it's the same chipset, but performance could vary based on the antenna placement on the device, or how many other radio interfaces you have on the device, and so on. So it's very, very important to, as we said in this presentation, to test the device at various stages. So basically, at each stage in isolation. So you need to do RF testing to make sure the transmitter and receiver can function well by themselves. You need to do MAC layer testing to make sure the MAC protocol aspects work well. And then we need to test the whole system together as well in a very, very, very methodical approach.
Okay, we had another question come in for Sean. Sean, you talked about the agent software. How do you port it into the device under test?
Yeah, no, that's a great question. So we have the Wave agent stock that can run on several different operating systems, most flavors of Windows, Mac, iOS, Android. If you need a custom agent, if you have a custom operating system like Green Hills or some derivative of Linux that's proprietary to you for an embedded device, work with me. I can get you the necessary documents to sign, and then we can give you the source code so that you can then do a custom port. We say take 2 weeks, but I've never seen a custom port. Only in one instance I've ever seen it take more than about 2 days. So it's not too daunting of a task. And what's great about the agent is really amazing, because what's great about the agent is you can use it with the AP emulator. You can use it with real APs in order to measure the QoS while you're doing things like roaming, like Cinerama was talking about. And then in a real customer environment, you use that same agent, the same agent that you just did all this testing with the AP emulator, with the real APs for interoperability. Use that same agent in the field, and it's really fantastic when you can use our WaveDeploy site assessment software and be able to run an application like Link, to be able to run voice and video from your real device with no interfering elements to the radio or to the drivers or to the OS on your device, and really get the performance of mission-critical applications on your real device. The agent is very, very powerful.
Okay. We had another question come in for Cinerama. Can this product to test the AP, can it be used to test the AP instead of a Wi-Fi device? If not, what product should they look into?
Can you repeat the question, Kyle?
Right.
Sorry.
Can the product be used to test the AP instead of a Wi-Fi device, such as a smartphone? If not, what
Yeah.
product is better used to test the AP instead of a Wi-Fi device?
Yeah. So yeah, again, excellent question. So so this particular product that we talked about, we cannot use it for testing access points, but we have a whole other product line that is actually built for testing access points and wireless LAN controllers. And in that particular case, we will use our equipment to emulate one or more golden stations. So in that case, that's a whole different way of testing. We can use the similar hardware that we have to emulate hundreds and hundreds of wireless stations, golden stations, that can connect to the access point, load up the AP with lots of traffic, and then do different types of tests like QoS, performance, load balancing, all kinds of different things. And we have a full product line there, and we have a whole bunch of customers that use that product today. If you have more questions about that, please feel free to reach out to us after the webinar, and we'll certainly give you a more detailed presentation on that.
Okay, thanks. Another question coming in, also for Cinerama. Can you differentiate between AirMagnet and WaveDeploy?
Yeah. So AirMagnet, for the most part, they actually do like site surveys. So AirMagnet tools, for the most part, they do site surveys, and we talked about the difference between a site survey and a site assessment. As we mentioned, site surveys where you actually walk on the floor and make coverage measurements or signal strength measurements at various places on the floor. Now with our tool, and I cannot speak to exactly all the things that AirMagnet does, but from our point of view, what we do is we not only do passive site surveys, but we also do active site assessment. So what that means is we can take a certain type of smartphone or a client device, run a series of tests from that device on the network at various locations on the floor, and tell you what kind of voice quality or video quality that you can expect on the device at various locations on the floor. Now, what we also have is a hardware solution for field testing, which is where we have a small piece of hardware that can emulate up to 64 golden ideal stations that would connect to the wireless network. So what this allows us to do is now test the real client on a real live network, but we can use our hardware to load the network with lots of background clients and test the client device under loaded conditions.
I just want to re-emphasize the importance of the difference of being able to run active application traffic. For instance, being able to guarantee or certify a hospital network by running a electric medical record application on the device, and not the real application, but our interpretation of the application, so that you can verify in all areas of the hospital. We ran an electronic medical record application, and it passed the SLA everywhere. Or we ran a heart monitor, which is a very high QoS, because it's a very latency sensitive application, and it passed everywhere. Or we ran a very high throughput application like an X-ray or a high-res medical imaging application, which has really high bandwidth, but it's not quite as time sensitive. We ran that in all the locations it's being used, and the actual application traffic, the actual quality of service was verified to pass. So it's very, very powerful, much more powerful than a site survey that just says, hey, the power is good enough here to get quality Wi-Fi, whatever that actually means.
And Sean, kind of going off of that, we had another question. If you could just explain a little bit more about the FDA Coexistence Testing.
That's a great question, and there's probably not enough time on this call to go into it. And Ixia has been working for a long time with some medical device companies, and the FDA just issued some new guidance about 6 weeks ago, maybe, which is a little bit rare for them to do, but it basically centers around the desire to have medical devices now tested in a real environment, in a real hospital environment, and to have coexistence with other wireless devices. Now this is something that we've been doing in the lab for quite a long time by emulating the traffic of a hospital, by emulating dozens of client devices, dozens of heart monitors or infusion pumps or X-ray machines, so you can really test your medical device in the presence of all this other traffic in the lab. And what the FDA is now saying is, hey, what we really want you to do is go out into a real hospital and test with the coexistence of other wireless devices or other Wi-Fi devices, and go ahead and just assure that you're not interfering with them and that they're not interfering with you. And it's something that we will probably need to go into more detail about to answer the question fully, so please feel free to contact me. But we also work with David Hoagland at Integratech to have a test plan for that, and you can certainly contact him if you know him, or contact me, and I can get us all in touch with the right people to look through that test plan and get more information. We also have a a webinar and a white paper online. If you go to ixiacom.com, you can get those.
All right, thanks. We have another question coming in for Cinerama. Is there a report generator tool that can be used to get an executive report by compiling multiple test results?
Yeah, so that's something we do it as a part of the Wave device software that we're talking about, where we can actually run a series of tests. For example, let's say you want to test your client device against different types of access points. So that's one of the things that the Golden AP product can do very easily is we can program the hardware to look like many different types of APs. And then we can very quickly through automation put the device through its paces, make the device connect to different types of APs on different frequency channels with different settings and so on, and we can gather all the results, and then from the results we can create reports as well. So that's all part of the software tool that we have.
Okay, we have time for just one more question for Cinerama, but Sean, feel free to chime in. How does the coexistence of other Wi-Fi devices impact my own device?
Yes, I mean it does quite a bit, right? So if you look at the Wi-Fi protocol, basically it's a shared medium, right? So the way it works is if you have an access point, you could have an access point in a wireless network. You can have several devices connected to that access point, and they're all sharing the medium. And unlike other access technologies, there is no dedicated time slots or frequency channels allocated to each one of these devices that are connected to the AP. They all share the same medium, and they have to contend for the medium. So if I'm making a Wi-Fi client device, and I could be the latest and greatest Wi-Fi client device using the best possible and the latest technology out there, but all it takes for my device to perform poor is to have another poor performing device in the same connected to the same access point. So a quick example, you could have your client device could be 11AC client device connected to the 11AC access point, but let's say there is a legacy 11G client device connected to the same AP. Now anything that particular device transmits takes up more media time, and hence brings down the net throughput of the wireless LAN cell. So yeah, interoperability is a big piece, and coexistence is a big piece, and performance devices is affected a lot, and that's why we have a lot of we actually have a lot of test cases in our tests that we do for interoperability testing.
Wi-Fi is like a little dance, and every client device kind of dances a little bit differently, and the AP has to kind of adjust to the way that client device is trying to dance. And like people, some devices just don't dance very well, and they make it very hard for anybody else to kind of get in and in this example dance. But what the real example is to get their video through, to get their important data through. And Cinerama said it fantastically well, but I just love that dance analogy so much I had to chime in. But use Cinerama's answer instead of mine.
All right, thanks. That's about all the time we have. I want to thank Sean Baioni, Wi-Fi Business Development at Ixia, and Cinerama Penumetsa, Product Manager at Ixia. And thank you everyone for attending Guarantee Mobile Device Performance presented by Ixia. Thank you.